Scientists at Columbia University say volcanic rock buried deep below the coast of the eastern seaboard could hold the key to storage of CO2 from power plants. A study in the Proceedings of the National Academy of Sciences outlines formations on land and offshore where scientists say the best potential may lie for carbon dioxide storage, including New York, Long Island, and Massachusetts. As opposed to pumping emissions into shale or pumping liquefied CO2 into sedimentary sandstone offshore, this new study looks at basalt, an igneous rock. Here to talk about it by phone from New York is one of the study's authors, is David Goldberg, director of the Borehole Research Group. He's also senior scientist at the Lamont-Doherty Earth Observatory at Columbia. David, thanks for being with us.
Yes, Susan, thank you for having me back on the show.
Yeah, it's good to have you on again. Now, you were on once before talking about volcanic rock buried deep below the ocean floor. Now, this was in the Pacific Northwest, off of Canada, Oregon, Washington, British Columbia, as a possible key to storing huge amounts of carbon dioxide. Now, is this a similar finding off the East Coast in New York and New Jersey and elsewhere?
Yes, indeed. That study on the West Coast prompted some thinking on the East Coast for similar kinds of rocks, these basalt formations, which are not well studied offshore on the East Coast, but onshore quite a bit. And we've been doing that for some tens of years now.
Okay, now tell us what makes these areas these ideal reservoirs for CO2.
Well, the basalt formations on the East Coast are basically in the 200 million year plus age range. So they're not youngsters like they are on the West Coast. These are formations that were deposited more or less at the formation of the opening of the Atlantic Ocean. So they're in ancient basins that are buried below the surface of the seabed. They bed quite deep. We think as much as a mile or so. And these basalt formations lava flows basically are relic from that era.
Now, the finding in the Northwest was for some, I think, 30,000 square miles of ocean floor off of California, Oregon, and the other areas. 150 years of CO2 production in the U.S. You were talking about then. What's the potential for this new find on the East Coast?
I don't know, Susan, if I'm coming through, but I just heard about
just the potential for CO2 storage. How big is it, and what you've found so far on this side of the coast?
Well, I think the formations look like they have an open and injectable space in them, based on what we know from on land, that is reasonably large. And in fact, some of the even smaller basins off the coast of, say, New Jersey, have buried basins that may hold enough potential for storage of several large billion-watt power plants, for example. So we have to confirm all this with more research,
right.
But indeed the potential is there, and I think it's really has some major advantages.
Okay, so these potential emissions from power plants can be captured, they're sort of liquefied, and CO2 is injected into the basalt. And tell us exactly what happens scientifically. It actually turns into a solid?
Well, yes, we're assuming that in fact the capture and transport of CO2 in pressurized form would happen at a power plant, and then we're looking for a location where it could be injected relatively easily into one of these basalt layers. The layers we're actually looking at are the rubbly fractured ones that would be easily injectable. The basalt on top of those layers acts to hold and seal whatever is injected down, and then there is in fact sediment that is like a blanket on top of that. That indeed is below the water. So it's nice and secure in there, and it stays there long enough period of time. The reactions between water, carbon dioxide, and the basalt rock will convert to a carbonate, it's called, a form of limestone or chalk over time, which really is a secure and permanent solution.
And is that what makes it superior? I mean, are you able to speak to how this compares to other means being talked about carbon sequestration, or the advantages of these being undersea locations?
Well, yes, I think this is the fact that it's basalt, and there are other both on land and as we discussed earlier about the Pacific Northwest, other below the ocean basalt formations that have this advantage of mineralizing the CO2 into a permanent solid form over time. The fact that it's offshore has advantages as well, and that would hold for whether basalt or even a sandstone or another formation offshore that was used as a storage reservoir. And indeed, the ocean is has that covers the basalt or any layer that you would then ocean water. It is away from private property as well, so you have different regulatory issues, of course, but less private property issues. And I think that any water that you would pump in and pump out from the reservoir would be easier to deal with if it was seawater being returned to the ocean.
Okay.
So that would be the ultimate benefit of the ocean, any ocean sequestration option.
Right. So where does all this research go from here? I know later this year it's going to be tested in Iceland.
Yes, there's basalt on land testing sites in Iceland. There's a site in the Pacific Northwest, a very similar formation that's getting having a pilot study done in the coming months or year. And this would be quite similar to where we would like to end up with some of these East Coast basalt targets down the road. First, we need more exploratory research and a coring and surveying to be done to exactly identify where these basaltic basins exist and how deep they are and test all of our hypotheses.
Right. All right, we'll be watching to see where all this goes from here. David Goldberg, fascinating study from Columbia University. Thank you so much for joining us.
Thank you very much.